fish. Before we dive into it, can someone tell me, is this a male or female specimen?
I think that's a female.
You think it's a female?
Because it doesn't have a massive
Female?
forehead.
I think it's a male.
It has the vertical stripe.
I'm seeing that too. I'm going to disagree with you guys. I believe this is a male salmon.
I win.
And I'm not even looking at the colors at all. What I'm looking at, those teeth right there. Those are some pretty gnarly teeth. And you don't really get these kind of canine teeth, these front teeth, on the female salmon the way you do on the males. They have really small needle-like teeth up front.
And also 3 out of every 4 salmon here are male.
3 out of every 4 are male, so statistically, this is more likely to be male, just based off that, exactly. Now, I want to pass something around, it's really cool, just to show off the prominence and stature of these teeth. I want to pass around that kite there. Just gonna pass that around so you can see how big those front teeth are. It's clean. That's
I mean,
that has been
pretty sure.
detached from that fish for at least 2 years, so it's clean. So we have those prominent canine teeth at the front of our male salmon's mouth. Inside the mouth, the tongue is quite interesting on these things. They are always black on Pacific salmon. So all Pacific salmon have a black tongue.
Oh.
And on the
I didn't
tongue,
even know they had a tongue.
on the surface of the tongue is 6 teeth that point backwards. So they have bony teeth on their tongue. Some do, some don't. This one only has a couple. They're really small. Some have pretty prominent teeth on their tongues. Our fish is going to have a nostril on either side of its snout. So a nostril just like a person has on their nose. And their sense of smell is very acute. They can smell fresh water in the salt water from 100 kilometers away. They can differentiate the Goldstream River from a different river from 10 kilometers away. Yes.
Are we gonna like clean that salmon off before we dissect it?
Probably not, just because the inside will be very visible. So I can wipe this off.
Don't take away the awesome.
But
It's patina.
But yeah, they all come pretty dirty. So, really good sense of smell on our salmon. We talked about the eyesight. On the chum salmon, the large ones, especially the large specimen, the eyeballs can be the size of a person's. When you're holding an eyeball in your hand, it looks like a human eyeball. They're very large. Their visual acuity is good. They can see very sharply underwater, like a person would with goggles on. Their depth perception is very poor. They can only see 5 meters ahead of them. They have a much wider field of vision than people, and they can swivel each eye. They can move each eye independently of one another, which we cannot do. Our eyes move as a pair. Salmon can move each eyeball on its own. That gives them pretty good eyesight and ability to be able to see behind them a little bit, and really good peripheral vision on their sides. And of course, their eyes are located on the side of their head, and this gives them, really wide field of vision. Behind the eye is this part here. This is how our salmon breathes. These are the gills of the fish. So just like we have lungs, take a deep breath of air. You feel your lungs inflating. Salmon don't have those. They have gills. And gills pull oxygen out of the water instead of the air. So there's oxygen in the air that we breathe. There's also oxygen in the water. And the salmon are underwater, so they breathe in the water using the gills. I'll take a gill out here. So there's a gill.
Hey, you said that the
There's
word gill
there's
was
4 of
bad.
these on each side of the salmon's head.
So
It's made out of 3 parts. First, we have these feathery bits here called the gill filaments. And this is the main part of the gill. This is what actually pulls the oxygen out of the water. There's a lot of blood vessels towards the surface of these, and that absorbs the oxygen. Holding the structure together is this cartilage arch called a gill arch. It's made out of the same material, cartilage, like your nose and your ears. So if you pinch the top of your ear, that's what this feels like. And then on the inside is more cartilage, these little teeth-like things. These are called gill rakers, and these are important because our salmon breathes with a giant hole in its head. What happens when it tries to eat something? That thing could just swim out of its head. So these gill rakers act like a fence that trap the food inside and make sure that the food goes into the stomach rather than outside the side of its head. That would not be so good. That's the gill. Covering the gill, listen to this. It's that hard bony plate there called the operculum or the gill plate. Why would we need something hard and bony right here?
Didn't animals have that, or was that already there?
Nope, it was already like that. And we'll talk about what that is in a bit.
Pretty sure that's its butthole.
They're very vulnerable. So if I were to nick the gills of this fish, if the gills were to get cut, all the blood in the fish's body would exit through the gills. So that's not such a good thing, obviously. Our fish would die in that case. So it needs this extra armor over the gills, because the gills are essentially an internal organ that it uses to breathe. That is very vulnerable to being harmed because it's basically on the outside of our fish. So this operculum is really important. Without that, our fish would not survive so long. The skin of our fish is pretty slimy. You can see I can scrape up this layer of slime here. And some of them are a lot slimier, especially when they have more scales. That's a mucus layer, and that's important to keep different pathogens, viruses, and stuff off of their skin. It also makes them really slippery. Being slippery is important for a fish, especially when they enter the river. There's not that much water in the river compared to in the ocean. So oftentimes they're coming up to rocks that they need to get between or over, and that slime helps them slip over rocks in between them. Also, being slippery helps them get away from potential predators, something that can grab them like a bear or an eagle. Our salmon is able to get away from. Under that slime is scales, and scales are pretty hard to slice. Like, they're not, I'm actually putting pressure and it's not cutting, but it's really important to get away from bears and eagles, because when it comes to penetrating the scales, very easy. My knife just sticks through them. So, eagles have talons, bears have claws. Those are both lethal weapons to salmon. And you do find a lot of salmon dead in the stream with puncture wounds on them from birds just trying to grab them. So the scales are not that tough against things trying to poke them. And then under the scales is mostly what we're seeing right now is the actual skin of the fish, is all this white. So the skin of our salmon is white, and that's because these scales have either fallen off due to old age and warm temperatures, or been chewed off by a parasite called sea lice in the estuary that attack their scales and pull them off. We have several fins on our salmon. Up front, we have the pectoral fins, just like we have a pectoral area by our chest. These are like little arms on our salmon. They help steer it in the water, so it turns its body using these. And also these fins back here are called the pelvic fins. So it works in tandem. It uses these to steer itself. It looks the same. So it's not one on each side.
It looks black. The face is blacker on the other side.
Yeah.
Yeah, because the eye has been completely taken out.
So think of these like the little arms and legs. They're going to steer our fish. The next pair of fins is the dorsal fin up top and the vent fin down low. And mind you, these are normally less broken than they are right now. The fins take on quite a lot of damage in the river. They get really beat up, so we're seeing the raise of the fins here. But a lot of that connective tissue is gone. So these fins work like the feathers on an arrow. So they stabilize our fish upright in the water. And without these two fins, due to the shape of our salmon's body, if it did not have them, it would just spin in circles endlessly. If it did not have these fins.
Are the tail connected?
Yep. And lastly, or actually not lastly, we have the tail fin here. We call this the caudal fin. And this is where our salmon generates all its power from. So it has a lot of muscle in its tail here, also known as the wrist of the salmon, or it has a funny scientific name. This bit here is called the caudal peduncle of the salmon. And this is where our salmon gets all its power from. So it wiggles that from side to side and pushes itself through the water. And lastly, we have a tiny, tiny, tiny fin here that doesn't really do a whole lot. It's called the adipose fin. And back in ancient times, at the end of the Ice Age, when glacial melt was filling up our rivers and they were running really hard, this was a secondary kind of organ that would help them stabilize in really fast, turbulent water. It's no longer needed anymore, so I can actually tell this is a wild salmon because it has its adipose fin. This is raised at a hatchery by people. They cut this fin off when it's a baby, so it grows up without an adipose fin. When it returns, they know it came from the hatchery. And if they don't cut that fin off, what they do is they take a hole puncher and they hole punch the operculum here. And just put a hole in that. So that's the outside of our salmon. Any questions so far? Yes?
Do salmon's shirt?
I don't know, probably. Yeah. They do have a vent. That's where all the poop comes out.
Oh, it's like a vent.
Yep.
Cool.
And do we have any more questions? Or, yes?
Can we slice its belly open?
That's what we're doing right now. So,
Oh boy.
we're going to make our first cut into the salmon here, starting from the vent. The vent is the one hole in our salmon where all the waste and reproductive fluids and eggs comes out of.
Oh yeah.
Cutting open his vlog.
Whoa.
You're gonna that. That is really gross.
Hey, the word ew is banned.
Wow, right?
But it is so gross.
It's like how it works.
Interesting. Ew.
Stop saying that word, it's banned.
Oh, check that out.
So,
I'm gonna throw up.
usually I say you were correct. I was correct. This is a male salmon. These are the milk sacks of our salmon. They are completely deflated at this point, so this salmon, good for him, has spawned, which is great. A lot of them, you find the milk sacks about 6, 7, 8 times bigger than this. That's before they've released the milk. These are fully deflated. This salmon has spawned, which is great. This is the male reproductive organs. So this is the salmon's balls. That's what they are. I'll put it bluntly. They get really big in the months leading up to spawning. And they get so big, along with the egg sacs in the females, they press on the stomach. And the stomach gets so stressed it can no longer accommodate food entering the digestive tract. So our salmon starve because they physically cannot accommodate food any longer.
So is that a part of their death cycle?
Yes, yes.
That's so interesting.
That, and then there's a change in their DNA, so they start aging very rapidly
Right.
at about 4 years old for the chum. It's a shift from youth to old age in like a blink.
Senescence or something,
Yes,
right?
yep. But that is also one of the primary causes of mortality, is they're not able to maintain sufficient energy levels. And if salmon did not suffer from that issue of not being able to intake calories, they would have the potential to spawn twice. But no salmon spawn twice because of that starvation, paired with the toxicity of the river that they enter, and then also that switch in their DNA to age them way more rapidly at their floor. Yes.
Is that toxicity because of human involvement in the river?
It's petroleum. It's also other minerals they're not used to as well. So their kidneys are going over time. And I'll talk about it now, actually. So salmon are saltwater fish for most of their life. They are looking for that salinity in the river when they enter. They're used to gulping in salt water. And they gulp way more water in the river because they're looking for that salt. And they can't find any, but they're pulling in tons of trace toxins. And that overloads their kidney eventually. And so we'll see the kidney in a bit. It's very large and like soup at the end. It's like it's not even solid. It's pretty gnarly to see, and that's one of the reasons that they die.
Can we take its brain out?
Oh, we will. Don't worry, we will. Oh wow.
There's food in there.
No, hasn't been eaten for a long time.
Is that its stomach?
No, this is
Be patient. He's gonna tell you.
this is really crazy. Oh, I see what happened. The gallbladder ruptured, maybe, but it's still there.
Yeah, it's attached to the outside of the liver.
It's not ruptured though. This is the greenest liver I've ever seen in a thing. This is disgusting. I'm breaking my own rule here. This is crazy. This is the liver. This is the liver of the salmon. This is not normally this color. It is normally pink. And the liver does the same thing in the salmon's body as it does in ours. It filters toxins out of the bloodstream. So any poisons that accumulate in the bloodstream of our salmon, the liver filters, and you can see it's quite enlarged and also doesn't have much of a shape to it right now. It's kind of just liquidy. Attached to that is this green sac called the gallbladder. This contains a digestive enzyme that helps process fats in our salmon called bile. And if I pop this bile sac, it should be all green. Yeah, you can see that dark green liquid there. That's all the bile on this leaf. Yeah, that's the bile there on my glove.
Whoa, that's like.
So what they used to do at the nature house here for a fundraiser is they used to get the employees to dye their hair green with the bile of the salmon. Good thing I'm not blonde, first of all. And good thing they don't do that anymore because that is horrific. But it dyes hair. Don't use that information ever. Great.
Ew, that is gross.
Yeah. I'll allow it that time. I'll allow it. I'm going to allow that one.
Oh no. Ah!
All right, what I got here is the digestive tract of our salmon plus one other organ. And I'll take that plus one off first. This little bit that's attached here, this non-digestive organ, this is called the spleen. We also have a spleen in our body. It does the same thing in our salmon as it does for us. It makes something called a white blood cell. And white blood cells attack pathogens in the bloodstream. It's part of our immune functioning. It keeps us healthy. And it does the same thing for our salmon. So this would attack viral pathogens, or the cells produced within this organ would attack viral pathogens. It takes on this pink color because it interacts with blood quite a bit.
Does it know what pathogens they come in contact with?
Mostly different kinds of viruses. Yeah, fish, I don't know the exact strains or like types of viruses, but fish have a lot of susceptibility to viral diseases in the ocean. And they're starting to vaccinate salmon now. So they're actually doing injection vaccinations on salmon at salmon farms. When they're like little fries. They have a machine and that has a needle and they just like run them through a conveyor belt and vaccinate them. Because viruses are a huge problem in the ocean, especially in overcrowded conditions, which you would find when they're all running to the same place at the same time. Or in pens. Here's the digestive tract of the salmon. So it has a lot of the same bits that we have. The food first goes through the esophagus and the throat, which is right here, and then into the stomach, which is here, totally empty. Salmon's not been eating for a long time. Stomach is empty. Here's a difference that it has with people now. You see these little finger-like things here? These are called pyloric ceca, and these are found in the guts of fish, but not people. We have something called a small intestine instead. So this absorbs nutrients from the digestive food. Then that matter, whatever is left as waste, is pushed out of the large intestine through the vent as waste. That's the digestive tract.
Another question.
Yes.
When we eat fish,
Yep.
I've noticed like a wild salmon's meat is very different than one that's raised. Why is it so different?
Are you talking about the color?
No, like there's like lines in the wild salmon.
Yes, that's fat. So they feed them a higher fat diet to get the like marbling or the streaking. It's an unnatural level though, so it's unnatural fat dispersal in the muscle. And then also the Atlantic salmon are lighter pink because they artificially feed them carotenoids in their pellets to give them the color.
Interesting.
Whereas the wild salmon are getting wild carotenoids from crustacean shells, and they dye them much more brightly. So like sockeye flesh is red, whereas the Atlantic salmon is like kind of vaguely pink sort of thing. And then our chum is actually totally white inside. So our chum doesn't have any color to its meat. It's white. It does not eat the same food as like the sockeye and stuff, so it doesn't pick up that color.
Interesting.
So behind the digestive tract, I find the sac here. This is something that's only in fish. I punctured it, so it's not a balloon anymore, but it was before. This is the swim bladder of our fish. Does anyone know what a swim bladder does?
No.
No? I'll tell you then.
Elliot? You know? Nope. Okay.
Can you infer based off the name? Swim bladder. It's in a fish, and it's a balloon. It's a balloon. It's gonna be full of air.
Whoa. I didn't see it.
I know you're getting at because of the name, the word bladder, but it's actually, so bladder is just going to refer to a membrane that encompasses something. It holds air, and it's like a balloon, so our fish can actually burp out air from this, and it can swallow air from the surface, and it can maintain its buoyancy in the water. So this is to prevent our fish from sinking all the way down to the bottom, and also floating all the way to the surface. This helps it stay in the middle of the water column by having the proper amount of air in there. Then behind that swim bladder is all that kidney here. Fishermen will call this the bloodline of the fish, but this is the kidney. They have two kidneys, but they are fused together, which is what I would call one kidney. I think it's just one homogeneous strip that goes all the way from kind of the base of the tail, all the way to the chest. Quite a large organ, and you can see it doesn't hold any shape anymore. It's just goop at this point. It's totally hosed.
Absolutely delicious.
And then what is left of the heart of our salmon? Usually it's a bit more solid. You tiger? Yeah. That's the heart of the salmon. It's a pretty solid muscle. It pumps blood in our salmon's body. And not a super big heart. It doesn't need to be that big because it's not pumping as hard as a human heart would. We are upright beings and it needs to pump a lot to get blood up to our head and down to our legs. These guys are in the water and they're horizontal, so it doesn't need to pump that hard. Only difference with this and a human heart is this has 2 chambers, human heart has 4. It's a simpler heart structure.
Oh boy.
So the brain of our salmon is all right here. That is the brain. That is the brain of our salmon. All this white matter, and it fits in this little hole that's right here. That's the brain. The brain is about 1/3 the size of the salmon's eyeball. It's a very small brain, especially in relativity to the size of our salmon's body. It's a very small brain, and that is because of that instinct that they have. So we have to do a lot of complex tasks as human beings. We have to learn how to drive cars, have jobs. Salmon do none of that. They live all the exact same life, and that life is dictated to them by the generation before. So they do not need to think critically about anything. Therefore, not a whole lot of brain power powering their life. That doesn't detract from how incredible what they pull off is. The migration down here is absolutely remarkable, and just doesn't have that much to do with brain power, which is really cool. Man, let's see if we have a better eye here.
Does the head smell more than the rest of the body? Like, it smells better.
Probably, yeah. Oh, actually, all the blood is soaked up, and it's all coagulated. That's why it was so bloody in there. It usually isn't. Yeah, just 1 second. And the eyeball of our salmon, this one's actually quite small for a chum. That's a smaller eyeball.
Stab the eyeball.
And it's already been poked, otherwise I would get the lens out of there. The eye color, this one has been ruptured, but the eye color of our salmon is usually green or blue. And they can have really pretty eyes, actually. It's a weird thing to say, but they have remarkably blue eyes sometimes. Like these little flecks in them. So that's the eyeball. Yes. Oh, thank you. You can just put that down right there and I'll grab it. Thank you very much. So, the eye, very, very big, yes. On the bigger chums, which top out at about like 35 inches kind of thing, they can be the size of a human eye. The big males, it looks like even eyeball in your hand. They're big. This is a small one. So, yeah. Any questions before we move on?
The channel that he was showing the brain, like this spot where the eye is way bigger than the spot where the brain
Yes.
is. Like
Yeah.
3 times as
Yeah.
big.
Yeah. That's eye, and then the brain cavity there is much smaller. Yeah.
Are you able to see where the magnetite is, or is that?
I've tried and tried. You cannot find it. I've tried on so many specimens. I've never been able to locate it. It's tiny. It's tiny, and I think I don't even. Finding pictures of it is hard online. I don't even know if they ever.
Oh,
really
we have
picked
a
it
goal.
out. Like it's hard to find pictures online.
I'll race you.
Yes. What's that? It doesn't look too much different, honestly. It's just a headless fish at that point. But
You can have a look inside the head though. I'm sure he'll show some of that. There you go.
yeah. You can see how it's all clear there. So a lot of that structure is just the skull is made out of cartilage too, so it's quite soft actually. Alrighty, so if we have no final questions, I'm going to